In today's lesson, we're going to look at energy diagrams and see how they help us understand the difference between exothermic and endothermic reactions. By the end of this video tutorial, you'll be able to recognize which reactions release energy and which ones absorb energy just by looking at the diagram. So, exothermic reactions are the ones that releases energy to the surrounding. So we talk here about the system, and the system is the change. It's the substances that are undergoing the change. So the substances undergoing the change. Now the change could be physical or chemical. So when the system releases heat to the surrounding, as you can see in this diagram, the temperature of the surrounding will increase. Now, if the system absorbs energy from the surrounding, this means that the reaction, the change is endothermic, and the temperature of the surrounding will drop. So the first thing here, in an endothermic reaction, the system absorb heat from the surrounding and the temperature of the surrounding will decrease. So if I'm touching the beaker where the change is happening, the temperature, it feels cold to touch because the temperature dropped. Now if I have an exothermic reaction, the system will release heat to the surrounding, increasing the temperature of the surrounding. So the temperature of the surrounding will increase. And if I'm holding the beaker or the flask where the reaction is going on, it will feel hot to touch. Now, let's move on to explain what exactly happens during an exothermic reaction. So as you can see here, I'm presenting the system releasing heat to the surrounding. Now, you need to understand that in a chemical reaction, when the reactants react together, they need to absorb energy. They need to absorb energy in order to break their bonds. So energy is absorbed for bonds to break. Now, when the reactant absorb energy, they reach a transition state called the activated complex. This activated complex is an unstable compound. Like I'm saying, it's a transition state that will move the reactant in order to break their bonds and start forming new bonds to give the products. Now, in forming the products, energy is released for bonds to form. So, reactants absorb energy, they break their bonds, and then upon forming the products, upon forming the bonds between in the composition of products, energy is released. In the exothermic reaction, we have to compare the amount of energy absorbed versus the amount of energy released. And in this case, for an exothermic reaction, the amount of energy released is more than the one absorbed, than the energy absorbed. And that's why the overall will be heat released to the surrounding. And we call these reactions exothermic. Now, there's one important thing you need to know in their energy diagrams, or also what I can call enthalpy. So, first we start at a high enthalpy of reactant. Reactant absorb energy or I can also call this activation energy. So activation energy is the energy needed for the reactants to reach the transition state and start breaking their bonds. So here's the enthalpy of the reactant, and here are the reactant absorbing energy. Now, after they form their bonds, or while they're forming their bonds, the energy starts to decrease as the product releases the energy. So at this point, the products are formed at a lower enthalpy. Now the difference between the two is called enthalpy of the reaction. In the enthalpy of the reaction, it's always the enthalpy of product minus the enthalpy of the reactants. Now, since the products, they have a lower enthalpy than the reactants, the answer is always a negative value. And the enthalpy of the reaction is here, presented on the diagram. So, this is the activation energy. This is the enthalpy of the reactant. This is the energy released to form the product, and this is the enthalpy of the product. Now from the x-axis till the top, it's called the activation, activated complex. And the difference between enthalpy product and enthalpy reactant is what we know the enthalpy change of a chemical reaction. So here note that the enthalpy of product is less than the enthalpy of reactant. Now moving on to endothermic reactions. An endothermic reaction, as in overall, the system absorbs heat from the surrounding. So again, as I mentioned, reactants, they need to absorb energy. So energy absorbed to break the bonds of the reacting substances. So energy is absorbed to break the bonds, and again, energy is released to form new bonds, as you can see over here. However, in the endothermic case, the energy released is always less than the energy absorbed. So as an overall, we say that the system is endothermic because it absorbed heat more than it releases. Now let's look at the energy diagram. Here the difference is that the reactants, they start at a low enthalpy and they absorb a larger amount than what they release. This energy absorbed, again, is also called activation energy. So the reactant will reach a transition state called the activated complex. So here at the top, it is the activated complex. Once the reactants reach the energy state of the activated complex, bonds start forming, and here energy starts to being released. Now, since the energy absorbed is more than the energy released, the overall reaction is endothermic. So here are the products, and this is their enthalpy. Now, the difference between the enthalpy of products and enthalpy of reactants, it's called the enthalpy change of the reaction. Now, since the enthalpy of products is a higher number than the enthalpy of reactants, the answer is always a positive value. Now, that's it. So here again, I'm summarizing the exothermic and the endothermic reaction. You need to know that the exothermic reaction starts at a high enthalpy of reactants and they stop at a lower enthalpy for products. The enthalpy change of the reaction is always negative, that's delta H, and the system gives off heat to the surrounding. So if I touch if I touch the beaker where the reaction is going on, my hand is a surrounding, so it will feel warm to touch since the energy was released to the surrounding, so the temperature of the surrounding will increase. So again, exothermic reaction occurs when more energy is released during product bond formation than is required to break bonds in the reactants. Now the endothermic reaction, this is the enthalpy diagram. The reactants start at a lower enthalpy and they absorb energy, and when the energy is released, it stops at a higher enthalpy to give the products. So the enthalpy of reactants is less than the enthalpy of the product. So if we do the difference between them, which is delta H enthalpy of the reaction, it's going to be a positive value because the system absorbs more than it releases, absorbs heat more than it releases to its surrounding. And if I touch the beaker, so the beaker is a surrounding, the temperature will feel cold to touch. So as a result, endothermic reaction occurs when a greater amount of energy is required to break the existing bonds in the reactants than is released when new bonds form in the products.